Here I'm given a graph of f of x. It is actually the absolute value of x squared minus 4. And each of the 4 graphs below is the result of applying one or more transformations to this parent function f of x. For each graph, we're going to state what transformations were applied and give an equation for the transformed function. So let's look at A here. I got to try to compare it to the original. It looks like it's got the same general shape. This point is at 0, 4, so is this point. But this point is at -2, and down here it's at -4. And this point was at 2 in the original, and now it's at 4 in the transformed function. But no shift happened because this point was at 0, and it's still at 0. So it looks like I have a horizontal stretch by a factor of 2, because -2 went to -4, and 2 went to 4. So I have a horizontal stretch factor of 2. And to make that happen in the formula, right, I would have to do f of multiply by something on the inside. So this is a horizontal change, which always happens inside. It's a stretch, which means I'm going to do multiplication, but I'm actually going to multiply by 1/2 rather than 2, because inside changes are kind of the opposite of what you expect. So this would be f of 1/2 x. That would cause a stretch by a factor of 2, horizontal stretch by a factor of 2. And so now I'm going to take that 1/2 x and plug it into my original formula. So it's going to be the absolute value of 1/2 x squared minus 4. Okay, so the next one, B, we'll look at some key points and see what they did. This point was at 4, 0, 4. And now that key point looks like it's at 0, 2. So contenders for transformations that could have happened, I could have had a vertical shrink, or I could have shifted down 2. So let's see where these 2 points landed. That should help me decide. This is at -2, 0, and this is at 2, 0. And over here, this is -2, -2, and 2, -2. So this is starting to look like a shift. I shifted the whole thing down 2 units. This is a vertical shift down 2 units, which to make that happen, I would do an outside change because this is vertical. To go down 2, I subtract 2, which means that my final formula is the absolute value of x squared minus 4, that's f of x, minus 2. All right, so for C, this point is at 0, 2. Okay, my original point was at 0, 4. So I might have shifted down 2, or I might have compressed vertically. And these points are at -2, 0, and 2, 0. So it can't be a shift because those points didn't move, right? So in a shift, every point on the graph moves. So this could not be a shift. So I'm going to say that this is a vertical shrink, right? Because a vertical shrink would not affect the x-intercepts, because if you shrink your y values, if you multiply those y values of 0 by anything, they'll still be 0, so they wouldn't move. So this is a vertical shrink by a factor of 1/2. So that means I multiply each y value by 1/2. So I would have 1/2 times every y value represented by f of x. So that would be 1/2 times the absolute value of x squared minus 4. Okay, and then this last one looks like I definitely flipped it over the y-axis, sorry, the x-axis. I flipped it upside down. And I think there's also some kind of shift involved, Because if I had just flipped it upside down, this point right here would have landed at -4. And these points would not have moved. They would have stayed on the x-axis. So I think I flipped it and then shifted it up by 3 units. These would have stayed where they were after the flip, and then I moved them up 3. So this is a reflection over the x-axis. Followed by a shift, a vertical shift, up 3 units. So to reflect over the x-axis, you put a negative in front. And to go up 3 units, you add 3. Both outside changes to the formula. So this is going to be negative absolute value x squared minus 4. I'm just replacing f of x with its formula, and then add 3.